Today our topic is CPU scheduling algorithm. Before we start with CPU scheduling algorithm, I'd like to tell this is the continuation of process, and in previous video we have described whole second module and end of first module with the help of this diagram. In this diagram we have seen the processes are moving from ready state to running state with the selected by short term scheduler, and dispatcher will take the process stored in ready queue to running queue. And also I told it is just a model. It doesn't happen that process physically goes to CPU. It doesn't happen. Actually it doesn't happen, but still we, for our assumption and to know the flow, how the process is getting executed, these states are assumed. So you can presently assume that all the processes are present in the ready queue which are ready to execute. Now which process should be first taken to CPU, like which CPU will be associated with which process first, so that our actual execution gets faster. For that we have some algorithm that is called CPU scheduling algorithm. Okay, so in the context of CPU scheduling algorithm, we need to introduce some terms. First term is CPU utilization, then throughput, then turnaround time, turnaround time, then waiting time and response time. So CPU utilization means this is a basic of CPU scheduling actually. So CPU utilization means always, because most of the system we have one CPU or maybe 2 or 3 CPUs. So CPU should be as busy as possible. So we need to keep so many processes ready in the memory so that when CPU executes one process, it can immediately shift to other process. CPU utilization is actually the if CPU is more utilized, your amount of work done per unit time will increase. That is what we want. We want the system to perform with the maximum efficiency. So if CPU is as busy as possible, amount of work done per unit time obviously will increase, and that is only nothing but considered as throughput. So throughput definition is what? Amount of work done per unit time. Now what is turnaround time, waiting time and response time? So to know this, first I will describe, then we'll go for the definition. So turnaround time actually it depends on arrival time and completion time. What is arrival time? Before we go for the actual thing, we will first tell what is arrival time. Let's say in your college starts from 8:20. So when you are supposed to arrive to the college 8:20. So 8:20 is nothing but your arrival time. Arrival time usually will be mentioned with AT abbreviation. What is your completion time? Maybe your college ends at 4:20. So if 4:20 or 4:10, if you leave the college at 4:10 only, sharp 4:10 only, then this is your completion time. But remember that if you arrived surely at that time, then only it is your arrival time. And if you actually goes back from college, you starts back to your home from college at 4:10. So this is your completion time. So what is your actual turnaround time? Definition of turnaround time is, it is your completion time minus submission time. So what is your turnaround time? Definition of turnaround time is, it is submission. Your submission time means you are submitted to the college at that time and you have completed your college at that time. So 8:20 to 4:10 is your turnaround time. So 4:10 minus 8:20, how much ever is the time, that is your turnaround time. Now what is burst time? Burst time is actually how much time you have executed in your college. That is your burst time. So suppose you have your first class started at 8:30. This is a rest time given for you so that you can just have your breakfast, all such things. So 8:30 your college started. Your first hour is 8:30 to 9:30. So this 1 hour teacher was there in your class. So it was your burst time. Then maybe you have got a break of, actually you are coming to college for studying. So how much time you have studied, that is your burst time, and assume CPU is your teacher. So how much time teacher was with you, that is your burst time. So maybe 8:30 to 9:30 you had a class, then your next class is from 10 to 11. So this 1 hour is another burst time. So like that, similarly, maybe 11 to 12 also one teacher was with you. So this is your burst time. Then maybe 1 hour gap you have got. Then 1 to 2 teacher was with you, and 2 to 4:10 your teacher was with you. So 1, 2, 3, 4 hours. Here 5, 6 hours 10 minutes. If it is not wrong, calculation is not a 6 hour 10 minutes is your burst time. So what is burst time? The time teacher was with you. Okay. So what is waiting time actually? Waiting time is what? Waiting time is when teacher was not with you. When teacher was not with you, that is your waiting time. So maybe ideally teacher might not have come at 8:30, maybe teacher has come at 8:31. So this 1 minute will be reduced from here. This 1 hour, it will be taken as 59 minutes, and 1 minute will go for waiting queue. Maybe if this teacher came at 10:10. Not only that, 12 to 1 you have got a break. So 12 to 1 you have got a break time. So this 1 hour, this 1 minute, this 10 minutes. So 1 hour, 10 minutes. So 1 hour, 1 minute, here 10 minutes, and here also half an hour some short break we have assumed. So 1.5 plus 10 plus 1 minute, that is your waiting time. Okay. What is your response time actually? Your response time is nothing but after your arrival, when you got the first response. When you got the first response here, response means I told like when CPU is first attached with the process. Here it is when teacher was first attached with you. What is that time? 8:31. When you have entered 8:20 you have entered, and 8:31 your first teacher entered. So this 11 minutes is your response time. Remember that response time is a moment of time. Like it is just at that particular time, 8:31, you got response. Remaining when and all teacher came is not considered for response time. It is not summation of time. It is not a duration. It is a just from your arrival to your first response. Remaining teachers and all, like for the case of CPU, when the process got CPU again and again, next time, is not considered here. Okay. So hopefully this part is you have understood. Now I will go through the definition and I will. So your definition of turnaround time is interval or duration between submission of a process to completion of a process. When the process is submitted to the system and when it is completed. Like when it is completed means I already showed you. When it is entered to the new state, that is the submission time. When it is terminated from the system is your completion time. Now, response time, waiting time, sum of the period spent by the process in ready queue. Why? Please concentrate on the term sum. It is SUM sum, not SOME sum. Okay. So, why it is sum of the period spent? Because you can see here, already in previous video we have explained processes are present in the ready queue. It has entered to the running state. From there, because of 3 reasons, it may again enter to the ready state. But from running state, process can go to waiting state because of the deficiency of some other devices. Okay. Again, after getting those devices, it will be ready. Maybe process has gone to waiting state because at the time of running, it requires one printer. So it has gone to waiting state. From waiting state, when it will get again printer, it will go back to the ready queue. Okay. Maybe for getting printer, it has waited 1 minute. Again from ready queue, its turn will come. It will come to the running state. Again, maybe it requires scanner while executing. So again, it will enter to the waiting state. Maybe for scanner, it has waited in the device queue of scanner for 5 minutes. So previously, what I told, maybe 1 minute. Now it is 5 minutes. So summation of these two will be considered as waiting time. So total covering this state, how many times process has entered to the waiting state, and in waiting state how much time it has spent, how many times it has entered, that many times how much time it has spent, that summation is called your waiting time. So only we have used the term sum of the time. So we have used the term sum of the time. Response time is what? From entering to the system when the process got first response is called response time. With respect to this diagram, what you can imagine is 9 o'clock if the process has entered to the system, maybe 10 o'clock it has entered to the ready queue, and the 11 o'clock it might have got the CPU for the first time. So 9 o'clock to 11 o'clock is the response time. Okay, there is no summation, there is no addition of response time when the CPU, when the process, if the process gets CPU once again. Okay, so hopefully you are clear. And here few things I have noted down, like what are the things you need: arrival time, completion time, burst time. Burst time is already I have explained. Okay, it is the actual execution time. Burst time is actual execution time. Turnaround time is, so few things you just note down, that is turnaround time is what? Completion minus submission. Waiting time is what? That is your turnaround time minus your burst time. Burst time is the time when CPU is attached with the process. So whenever CPU is not attached with the process, in our previous example, teacher is not in the class, whether you are taking break or teacher is late, these all will come under waiting time. Okay, so waiting time is total time you stayed in college minus the time teacher was associated with you. Response time is first CPU response time, okay, minus your arrival time. First CPU response, just now I told, maybe you got at 11 o'clock and you arrived at 9, process arrived at 9, so 2 hours is the, that point of time, that 11 o'clock you have got the first response. Okay, so that is your first response time. And one more thing, that is context switch, that I will describe when we will be going through the algorithms. So without wasting time, CPU scheduling is our topic today. So we should know how many CPU schedulings are there, why we have introduced with those terms. These terms are needed everywhere when we will follow the algorithms. CPU scheduling algorithm is divided into two. One is non-preemptive, one is preemptive. In non-preemptive category, you have FCFS, SJF. FCFS is first come first serve, SJF shortest job first, longest job first, LJF, HRRN highest request ratio next, and next is multi-level queue. In preemptive, we have SRJF shortest reminder job first, RR is round robin priority scheduling, then longest running time first. First, I would like to tell, before I introduce with non-preemptive and preemptive, we will discuss here FCFS, SJF. From here we will discuss SRJF, RR and priority. Multi-level queue in other video I will cover. This all we are not covering. In your exam, usually if it is asked, you need to only describe these two among non-preemptive and these three among preemptive. So be thorough with this 5 scheduling, it is must. It will give you 12 to 20 marks in your exam. So be very thorough with these 5 with different types of problems. All types of problems with arrival, without arrival, I will be discussing. First we will start with what is the meaning of non-preemptive and what is the meaning of preemptive scheduling. For the understanding of CPU scheduling algorithm, we need to first understand what is non-preemptive and what is preemptive scheduling. So in preemptive and non-preemptive scheduling, to understand that, we need to first consider a set of process, that is P1, we have taken here P1, P2 and P3, and burst time of P1, P2 and P3 are 7, 3 and 2. Arrival time for P1, P2, P3 are 1, 2 and 3. What does it mean? It means at the arrival time 1, how to understand in the basic step. Let's say your present time is 9 o'clock in the morning. 9 o'clock in the morning. Okay, if it is 9 o'clock in the morning, so 1 process has entered. So which process has entered? Process P1 has entered at 9:1. When it is arriving to the system, that time we will be taking as a reference time 0. Usually that is the convention. So arrival time is 1 means, okay, it will be easy for you if I give here 1 for the 0 for the first time, there will not be any confusion. But you need to remember that whether it is 0 or 1, when we will start drawing the chart, this chart name is NAT chart. NAT chart. NAT chart shows how is the processes getting executed, like which one is getting executed first, then which one is getting executed, whether it is partial execution or it is a complete execution, what is the waiting time, what is turnaround and burst time. Every calculation will be made based on the NAT chart. So NAT chart will be drawn from the data given for you in the exam or book. So let us come back. Arrival time for process P0 is 0. So let's say that 0th instance of time is 9 o'clock. So it has entered to the system. So if we are taking 0, let me take it 1 and 3. So 0th instance of time, which process was present in the system? That is only P1. Okay, no other process, because it has entered at 9:1, it has entered at 9:3. If I take one interval equals to 1 minute. So 0th instance of time, which process was there? Only P1 was present. If it is non-preemptive, please listen carefully. If it is non-preemptive algorithm means once the CPU is given to the process, it cannot be taken out from the process if it is not executed. What is the burst time for P1? 7. So it means what? After 7 instance of time, means according to the watch, if I take, it will be 9:07. 9:07 instance of time. We don't write the time and all. For first video, for your understanding, I am writing. So 0 to 7, what is the burst time of P1? That is 7. So 0 to 7, it is completely executed as it is non-preemptive. So we cannot take away the CPU from P1 even though the next process's burst time is less or next to next process's burst time is less. Okay, now at the 1 instance of time, P2 has arrived. So when P2 has actually arrived, at this time actually P2 has arrived, but it has to wait. P3 also arrived at instance 2. If I take it 1, if I take it 2, so at this time P2 has arrived. Now I am not following any algorithm, just showing you what is non-preemptive and preemptive. So P2 and P3 has to wait for completion of P1. So if I am following the first algorithm of CPU scheduling, that is FCFS, let me take that. So that first come first serve, which has entered first to the system will execute for the first time. So P1 has entered, executed. Now P2 has entered. So P2 also has taken for execution. What is work unit for P2? That is 3. 3 is the work unit. Work unit means burst time. Burst time means once it gets CPU, it takes 7 units of time to execute. Once it gets CPU, P2 gets CPU, it needs 3 units of time to execute, provided that the CPU should be given continuously for 3 units. If CPU is not continuously available in 3 slots or 2 slots, CPU should be given, but CPU must be anyhow attached with 3 units of time. So that is the meaning of burst time. So next P2 has taken for execution. I am writing P2. How much is the burst time for P2? 3. So 7 plus 3, it will be 10. What about P3? It requires 2 units of time for execution. So remaining next 2 units of time, P3 will be executing, and obviously P3's burst time will be added with this. Please understand carefully, because all other algorithm I won't explain that funda. We should just go through the algorithm. I'll repeat once. Burst time is the time CPU must be attached with the process. According to non-preemptive, we cannot take away the CPU from the process until and unless it is completely done. So 7 units of time P1 requires, assuming that CPU is free and there are only 3 processes present in the system. So CPU is only dedicated for 3 processes, no other disturbing process. So what is the situation now? At the instance of 0, no other processes are present, only present process is P1. P1 is taken for execution and it has executed completely with CPU and it has terminated. So at that point P1 is getting terminated from the system. So P2 next turn, as we are following first come first serve, so P2 will be taken by CPU. So P2 will be executing. How much time it requires? It requires 3 units of time. So 7 plus 3 at 10th instance of time, like 9, 10 you can write. 9, 10 you can write. Which one will be executed? P2 will be executed and P2 also will be terminating from the system. Next turn is for P3. P3's burst time is 2. So CPU should be attached with 2 units of time with P3 and ultimately at time instant 9:12 P3 will be leaving the system. So this is about your non-preemptive schedule. Now we will go for preemptive schedule. In the case of preemptive schedule, maybe we are giving priority for shortest job. Whichever is the shortest, that one will be executed first. So in this case, one small thing, even though I have not done it, so for the case of preemptive, I should tell you, even though we will not understand properly, when P1 is executed, it started from 0th unit of time, but 1 unit of time you can see there is a another process entering to the system, that is P2. At 0th instance I had only P1, so P2 has already entered to the system. At that time, if I consider always shortest job first, so which one is shortest? From P1, 1 unit is executed, so how much unit is left for P1? 6 unit is left for P1. And for P2, how much unit is left? Left is actually total unit. P2 has entered with 3 unit, and at that moment for P1 how much unit has to be executed? 6 units. So which one is the smaller one? P2 is the smaller one. So according to preemptive, what we can do, we can start executing P2. Okay, so P1 was only process, so it has executed, but when one more arrival comes, happens, at that moment, based on some criteria, your criteria may be the burst time. So whichever has burst time less, we can allow that process to be executed. So main aim to tell that is CPU can be preempted. CPU can be taken away from the process and it can be given to other process. That is called preemption on preemptive algorithm. One more line I should add. Please remember that non-preemptive means no taking CPU. Preemptive means can be taken CPU. So you remember, non-preemptive means cannot be taken. CPU cannot be taken. Once you have given the CPU, you need to keep the CPU attached with the process. So opposite is preemptive, means you can give the process to CPU. Later if some higher priority job comes, or your present criteria is you need to check the burst time, lower burst time will be given higher priority. So you can take away the CPU and give it to some other process. Please continue this for knowing all the CPU scheduling algorithm in details. Okay, please follow the next video.